Okay, moving forward with our triangles, we're going to focus on congruent triangles, and really what we're going to talk about are congruent figures and moving those into those, triangles, those three-sided objects. But there are basically 5 main ways to determine that triangles are congruent. We're going to go over those in the course of 2 days. But just understanding and the definitions will allow us to work with that. But just remember that 2 figures are congruent if and only if there is a rigid motion or series of motions that maps one figure onto the other. That's just a fancy way of saying that they're identical. And then if you have 2 congruent items, then you also have corresponding parts, and those corresponding parts are just the matching parts, and we'll go over some of those examples here. 2 triangles are congruent if and only if their corresponding parts are congruent. And if we look at this first example, now this is obviously, we're talking about congruent parts here and understanding that it's not a triangle. But seeing this, these 2 images, hopefully at this point, we understand that when we look at this, the things that match up, I should be able to understand that, angle A has 1 arc. Angle W has 1 arc. So I should know that those 2 angles are the same. Angle X has 2 arcs. Angle B has 2 arcs. I should know that those 2 angles are the same. And then keep going around. Y has 3, C has 3, so those should be the same. And then Z should match up to D because they have the same congruency markers. Looking to BC should be congruent to XY because it has 1 tick. CD should be congruent to YZ because it has 4. These are those congruent things which telling me what corresponds to what. And that's what they mean talking about those corresponding parts. And in this image, I understand that ABC, polygon ABC, is congruent to WXYZ, and all of it is in the name. Just think, we know that A, according to the name, A is in the same location as W. So A and W should be the same angle. They are. B should be congruent to X because it is in the same corresponding location, and we look at it, and they are congruent. So we can derive a lot of this information from the name, and sometimes without having to draw a picture or looking at a picture and determining a name. So with that, what we've done here is we have this check, and what I've done is according to the image. Okay, if I look at the top image, if I start at P, that's 1 arc, and then I travel through the increasing arcs, I would go P, Q, R, S, P, Q, R, S, and that is going to be congruent to, again, starting at 1 arc and traveling into the other arcs would be G, F, E, D, G, F, E, D. So I know then that those 2 trapezoids are congruent. So if I'm going to put this over here to make it a little bit easier to read with our question, PQRS is going to be congruent to GFED. Now, what does that mean? I should be able to look at this and say that I know that angle P is congruent to angle G because they're in the same location. Q is congruent to F, R is congruent to E, S is congruent to D. And at the same time, when we talk about line segments, I could come over here and look at the image, but I should be able to see that in order, PQ is the first 2 points making a line on that trapezoid, so that should be congruent to GF. QR is the middle 2, should be congruent to FE. RS, the last 2, should be congruent to ED. And then last would be, as we round the corner, right, I went from SP, that would be the same as D and G. So there you go, being able to distinguish that from the name. And then so we did just complete the congruency statement up here, just by looking at what is congruent to what using those corresponding parts. Now using those corresponding parts, of course, are definitions that allows us to do things. And I've gone ahead and labeled some of the parts here in example number 2, but understanding that RSV is congruent to TVS tells me then that V is congruent to S, so this one is 78 degrees. And it sort of looks like, there you go, 78 degrees. This angle R is the same as angle T, and then I know this is 90 because this V is congruent to that S. I also know then what sides, looking here, RS should be congruent to TV because their location's in the name, and then that tells me then later on that 2y minus 1 is equal to 24. So looking at that, if angle T is congruent to angle R, I know that they're equal, so therefore over here I have 90 plus 78 plus x is equal to 180 degrees, so 180 minus 90 minus 78 is equal to 12. So that angle measurement should be, or the value of x is 12, so that angle is 12. For those two segments I mentioned earlier, those two are equal, so we did some substitution, did some inverse operations, and found out, 2y minus 1 is equal to 24. Add 1 to both sides. This becomes 0. 2y equals 25. Now we got to divide by the coefficient, so we divide both sides by 2, and then y is going to be 12.5, right? Y then equals 12.5. And then that's how we could use that information using the definitions of congruency. In this diagram, some things that we should be able to recognize as we solve for x and y. AB is congruent to ED. So I know then to solve for x, I know if AB is equal to DE, then 3x minus 10 is equal to 20, because that is congruent to that. I know that angle D here is going to be congruent to B. So if angle D is 38 degrees, that means angle B is 38 degrees. Y here is this angle, and I can calculate that either way, but I know if this is 90, this is 38, then my triangle, 180 degrees, let me move this somewhere else. I have 180 degrees is the angles measurements of my triangle, equals y plus 90 plus 38, and then now I can solve for both x and y and find out what those values are. And there you have it. When I solved, I knew that the triangle equals 180 degrees, y plus 90 plus 38 equals 180 degrees. Combined like terms, I inverse operations, subtracted 128 from both sides to get my y by itself, and then y is equal to 52. Over here, I did the same thing. I did substitution. 3x minus 10 is equal to 20. Add 10 to both sides to make this 0. 3x equals 30, divide by 3, and then x equals 10. So there you go, using that corresponding parts information. Continuing on, understanding the three triangles theorem, or triangle congruence, it just states that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles have to be congruent. So again, if I have two angles, 1, 2, are congruent to a triangle of two angles of another triangle, then this last one has to be equal. They have to be congruent. Now, if you plug in some numbers and we say that, this is 80, this is 70, which means this is 80 and this is 70, well, that makes this angle measurement right here 30 degrees, right? Because all three of them have to add up to 180 degrees. Well, this angle has to be 30 degrees because you can only add up to that 180. One number is going to get me there. So it just sort of makes sense sometimes. Talking about your different properties, using third angles, and we'll go through a lot of this information, but let's see in class more. But Aika is folding origami dragons for a party. She says the angle ABD and CBD are congruent. Okay, so this measurement is congruent to this measurement. And then BAD is 58 degrees. Find CBD. Well, again, this is 90. this is 90, and if these two triangles are, or the angle measurements are congruent, well, I know that this angle measurement right here has got to be equal to 180 degrees, right? Equals some number plus 58 plus 90, subtracting 148 from both sides. And then x is going to be equal to 32 degrees. Well, we know that this is 32 degrees, and again, we have two angles that are the same here, so this has got to be equal to 58 degrees. So I'm not worried about this justifying what we're doing here, this two-column proof. What I'm worried about is, or want you to understand, is how to identify the information they've given us, label your graphs and your images, and work with that information. Okay, so once we have a picture, it makes things a lot easier. Solving the equation makes things a lot easier. So in this check, oh gosh, kite shown above is made of two congruent triangles. So BAD is the same as BCD. Oh gosh, that don't show up, does it? BAD is the same as BCD, which is equal to 45. 45 degrees. This is 90. This is 45 degrees, and we learned that these two should be complementary, so I know that's also 45 degrees, and that makes this 45 degrees. So ABD is 45 degrees. If I were to add all those up, 90 plus 45 is 135. 180 minus 135 is 45. So there you go. Let's see here. Proving two triangles are congruent. Now here, I'm not going to worry too much about what these written statements are, but just think about what they've labeled here. We know that J is congruent to P right here. We know that JK is congruent to MP. And then we know that L bisects KM. It bisects KM. Well, I know that that should be equal to that if they told me that. And I know that this angle measurement should be equal to this angle measurement because they're opposite angles or vertical angles, have the same measurement. And there I have two triangles. Two angles of this triangle are congruent to two angles of this triangle, which means the third angle has also got to be congruent. So there you go, looking at it, labeling it, seeing what information we have and what else we know and we have learned. So there you go. Oh gosh, and I'm not going to worry too much about this because it really is the same thing that we just did. But again, if I have these two angles are the same as these two angles, then I know that this angle is the same as this angle, and I know that this equals itself, right? XZ is part of both of those, and sometimes it's better if we separate the triangles so it's a little bit easier to see. So this would be X, this would be X, Z, Z, Y, W. I know that is congruent to that. That is congruent to that. This is congruent to that. This is congruent to that. So there you go. Now we can see that we have those two separate triangles, thus making the third angle congruent. So there you go. Separating it sometimes makes it a little bit easier to see that we shared an item because both of these share that side. Okay. So with that, continuing on, now here's two of the first ways that we can guarantee that we have congruent triangles, and it would be side, side, side. That's what this stands for, side, 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 which means that all three sides of one triangle are congruent to all three sides of another triangle. And then we'll have side, angle, side, where we have the side of one triangle, the included angle, and the side of the triangle are congruent to another triangle. So included is the big thing here, understanding included angle, and we'll go over some of that. So with these two things again, side, side, side simply means that three sides of one triangle are congruent to three sides of another triangle. And I will just say here that QRS is isosceles, right? QRS is isosceles. If it's isosceles, then I know that those two things are congruent. And it tells me that right here. I know that RT bisects QS. RT bisects QS. So that would be angle bisector. Bisects segment QS at point T. What else do I know? Well, I know then that, again, this side, both triangles share that side. So again, if you separate it, it's a little bit easier to see. This is R, R, Q, T, T, S. You know, these two sides, TR is the same length for both triangles. We know that, and then we know that. So there we go. We have three sides of one triangle are congruent to three sides of another triangle. Therefore, those triangles are congruent because of side, side, side. Okay, just thinking about that. Here, they had to do some distance formula. Okay, so I've gone and drawn the images in here, and I may or may not have these in the right locations. You know, I reserve the right to be wrong, and I do believe I am. But just in case, here's point J, 2, 5. This is K. L is 5, 2. And then negative 4, 4 is Q. Negative 3, 0 is N. And then 7, 1 is P. And they want to know, are these two things congruent? Is JK congruent to QN? Is KL congruent to NP? And then lastly, is JL congruent to PQ? That's the order we're in, and what they did was they went ahead and created they used the distance formula between the points. So they were able to find out the distance of JL, the distance of KLK, the distance of KJ, and so forth. So they found out, hey, these two are congruent. These two are congruent. They have the same values. And then lastly, these two are congruent. So there you go. They were able to say, hey, all three sides of the triangle are congruent to all three sides of the other triangle. And then again, this is how it would appear commonly. So if this is 4, I would hypothetically say if that's 4, then I know this is 4. If this is 7, then I know this is 7. And if this is 5, I know this is 5, just because they are corresponding congruent sides. So that is when we have all sides of one triangle congruent to all sides of another triangle. Here, doing the check, I've gone ahead and here's where we have the images, and they would have to come up, do the same thing. And I am not necessarily going to work through all of these problems, but let's say if we did the distance formula, find the side lengths of each triangle. Let's think about what is congruent to what. Just let's do that. AB is congruent to EF, okay? AB is congruent to EF. BC is congruent to FG. AC is congruent to EG. So those things are what's going to be congruent. Now let's look at it. Does FG look the same length as BC? It's not. When we do the distance formula, we would find out that it is not the same length, but I can look at, just looking at the slope, this is up 1 over 2, this one is up 2 over 2, so I see there's a difference. Whereas, let's see here, AC should be congruent to FG. Again, AC should be congruent to F. I just did that wrong, didn't I? Let me see here. BC is FG. Oh, no, let me fix that, right? Let's see here. I just said BC should be congruent to FG, and then when we look at AC should be congruent to EG. I don't really know for sure about that one. So I'm unsure, just given that this is the shape of the triangle. But let's see. I'm going to have to say no. But do I know that AC is not the same as FG? Is not congruent to FG? Does it matter? AC and EG, okay? So this is not an accurate statement. We don't care about that for side. What I care about is BC and FG. Those two sides, if they're not congruent, then it is. That's the difference there. AC and FG don't matter. We need to have the two corresponding sides determine whether they are congruent or not. Okay, so there we go. And then understanding what the included angle is. We talk about side, angle, side. So it states if two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle, then the triangles are congruent. What that means, included means, you can see here that this side is congruent to this side. This side is congruent to this side. The included angle is the angle between those two sides. Okay, that would be included. I know you're saying to yourself, that looks like group, but it is not grouped, okay? So that is understanding. We have, in this order, we would have side, angle, side congruency, side, angle, side, in that order. So coming over here, not really too concerned about some of this stuff, but what do we need to know? Let's see here. Just looking at this, we're trying to find out playground equipment appears to be made of congruent triangles if LK is congruent to LM, and then we know that JL is congruent to itself because they share that same side. An angle JLK, this angle JLK is congruent to JLM. Do we have enough information? Well, I hope that you can see that I have a side, an angle, side, and here I have a side, an angle, and side. So we do have side, angle, side congruency for these two triangles. Not worried about making the proof. I'm worried about being able to understand what we're seeing and label our drawings and interpret, analyze, and make a determination. Again here, let's see, what do we got going on with this kite? The kite shown appears to be made up of congruent triangles. Okay, I think they mean we have this centerpiece right here. So we have two different triangles, one over here and one over here. Tells me that DE, sort of hard to see, huh? DE is congruent to FE, all right? We know that EG, they share that line, right? Just in case you are having difficulty seeing it. They share that side. And EG bisects DEF. So if it bisects, that means this side is going to be congruent to that side. So do we have enough information to say that these two triangles are congruent? Yes. I have side, the included angle, and another side. I have the side, the included angle, and another side to have that proper triangle congruence. So just being able to look at that and use that information. So these are the first two uses, definitions that we're going to use for triangle congruency: side, 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 angle, side. And then we will work on more tomorrow, but it's just a matter of understanding those definitions and getting a clear idea of what they look like. And with that, we'll just do some practice.